What is up, guys, and welcome to the 13th video in this series. In this video we're going to be covering quite a bit, a lot more than we have in previous videos, but this is probably going to be the most fun video of the series, so hope you guys enjoy it. So what we're going to do is, this is what we want to actually achieve. So we're going to want to make it so we're running. Before, our guy would run through the walls. We wanted to have it so when he hits the wall, it says game over, and when you tap, it restarts the game for you. So that's what we're going to do in this video. So to get started, we are going to start setting up collision detection here. So before I was getting a couple errors. I think it's because I updated Xcode. Yeah, you're going to see right here. Xcode got an update, and it looks like Swift kind of, Apple changed Swift's syntax a little bit. So if you guys are getting errors now after updating Xcode, you can just go through this with me and just change a few things. But if you're not getting errors, don't worry about it and totally disregard this part. So you can just try to run it. It's going to say, we can now get rid of this override keyword and the init, because apparently Apple just doesn't want to have that there anymore. They're probably just trying to clean up the syntax. And for here, I'm just not going to question it, and I'm just going to like put in what the compiler is asking me to do, just so we can kind of get started again here. So, okay, it looks like also they changed the syntax for sets. You can see right there. So that's different. So you can just create the touches began method, do that. And again, guys, this is like, if you're not getting these errors because you didn't update Xcode, don't worry about it, because it's really not a huge deal. Cool. So let's just make sure this is running. And make sure we're good. Cool. So this is where we were at before. We have our guy running through our walls. And if you guys are getting confused with the two simulators I have up, I have a separate Xcode project, which I kind of like code out all the changes I'm going to make, and then I create the tutorial on top of it. So just don't let that confuse you. And now let's finally begin with collision detection. So the first thing we need to do is we need to go into our constants file right here. And we're going to add a couple more constants. So with collision detection, you have this thing called, you have categories. So you create a category for your hero and you create a category for your walls. And then anytime those two categories interact with one another, you set it up so that a function is called that you can use to make the game end. So just to organize this really quick also, I'm going to just add a few comments. These are going to be our configuration variables. Here are going to be just the initial variables, so things like our initial speed. And here we're going to have our variables for collision detection. So I'm going to say let hero category. It's going to be a uint32. That is just a 32-bit integer. If you don't know too much about bits and the such, don't worry about it. You can look it up if you want, but you don't really need to know to use it. And this is going to be kind of some funky syntax here. Also, another thing, the best thing you should do would probably just to like accept that you have to do this syntax with categories. I can talk. And yeah. So I'm going to say this for our hero category. I'm going to create our wall category, and this is all going to kind of come together in just a sec. And I'm going to put that to 1 instead of 0. So this sets up two different, why is it giving me a expected expression after operator? Okay, maybe that's just, if I try to run it, is that going to go away? Okay, yeah, that was just a weird Xcode thing. So we have our two categories set up. We have one set to 0 here and one set to 1. And this is just kind of how you set up categories. So now that we have that set up, we need to go into both our hero and our walls, and we need to set up something called an SK physics body. So let's go into our hero first. So let's go into the ML hero file. And just to organize this, let's create a couple different functions for the setup. So I'm going to make a function called load appearance. And just below this init method, I'm going to say func load appearance. And I'm going to copy all this junk into that function. There you are. Okay. And now I'm going to say load a physics body, just to kind of keep our code clean, so you can actually kind of go back and manipulate things if you want to. So I'm going to say func load physics body, manipulate things easily, I mean. Okay, so now that we have all that cleanup done, we're going to set the physics body of our ML hero. So I'm going to say physics body equals sk physics body, and it's going to have an initialization function with a parameter of rectangle of size. This is the one you want. So you're going to click that, and actually we need to change one thing. We need to actually pass in the size to this physics body function, because when you're creating your physics body, you have to give it a specific size. And a physics body, all it is it's an invisible rectangle, circle, or anything like that that surrounds your node. And that's the thing that actually gets called, is the thing that we'll call the function if it hits another physics body, if that makes sense. If that doesn't make sense, don't worry about it. It's going to make more sense as we go along. So we are going to say, instead of just load physics body, it's going to be load physics body with size. So we're going to give a CG size in there. And so this is the size we created initially for our body. So here I'm going to just create a variable to make this simpler. I'm going to say let size equal CG size make 3244. And now right here, instead of that, I'm just going to put size. And now when we want to pass this in, all we have to do is say size, and now we're good. Okay, so now that we have this, we can say physics body equals sk physics body, rectangle of size, size. And now that's all we need to do to actually create this physics body for our hero, at least to initialize the physics body. So now to configure the physics body, we need to set a few of its variables. So I'm going to say physics body, and you're going to have to say this is an optional because we know that we already set up the physics body, so we can say this and know that it's going to actually get called, because a physics body has the potential to be equal to nil, and that's why it's an optional. So I'm going to say physics body dot category bitmask. So this is going to be the category of the hero. So remember we created the two constants over here, and nope, not there. In our constants file, we have the hero category. So I'm going to set this equal to hero category. The physics body dot contact bitmask, contact test bitmask is what I'm looking for. I'm going to set this equal to wall category. So essentially all this is saying is when do you want the hero to register contact with another object. So it's going to, anytime a hero category runs into a wall category, it's going to register that that is a contact. And last but not least, we have to set the physics body dot affected by gravity equal to false. So by default, actually I'm just going to show this really quick. Actually I'm just going to equal to false, and I'm going to comment this out. By default, physics bodies are affected by gravity, and it's actually pretty cool. Sprite has a really good gravity environment that you can kind of mess around with. You'll see it in just a sec. Because if I run this, you're going to see that now that we've set up the physics we put that in the init method, so it's actually getting created. You're you're going to see our hero gets affected. Yeah, there he goes. He's getting affected by gravity. It's SpriteKit's simulation of the physics world. Kind of cool, kind of fun to mess with if you guys want to do that. But for our purposes, we are going to want to set that equal to false because we don't want our hero to fall through everything. So now that we set up that physics body, let's go into our ML wall class. We're going to do the same thing over here where we're going to say func load physics body with size, CG size. And actually this might just be easier to, let's just copy all this over. And then we can just change a few things. So the category here for our ML wall is going to be the wall category. And actually you can delete this completely because as long as you set the contact test bit mask in one of the physics bodies, you're good. You don't need to set them in both. I'm going to say affected by gravity equals false. And also be sure to, in your init method, you have to actually load that physics body. Oh, and also I'm going to need to, same thing that we did up here. I'm just going to create the size as a separate variable instead. So I'm going to say let size equal CG size make wall width, wall height. And instead of putting that in here, I'm just going to say size. And you can pass that in. Cool. So now if we run this, you're going to notice something interesting. Now that we've set the physics bodies of these two items, if you tap, you're going to see, as soon as you can see that now that the physics bodies are interacting with one another. So it's actually shoving our hero around. Because it's not affected by gravity, nothing's falling, but that's kind of an issue. So we need to go into our game scene and we need to actually set something called the physics world so that we can actually get that function call anytime those two things interact. So let's just stop that. We're going to go back into our game scene here. And right under this add start label, I'm going to say add physics world. And actually, we're going to clean this up in just a sec so that instead of having all these in the init method, we have kind of separate functions to keep things organized. So here I'm going to say, let me just run over here really quick. There's really just one line of code we need to do to actually configure our physics world. We don't need to actually create a physics world like we do with the physics bodies here, because the physics world is automatically initialized when you create a scene. So I'm going to say physics world dot contact delegate equals self. So hopefully you guys have worked with delegates before if you've had some experience with Swift or Objective-C, anything with Xcode. Basically, a delegate, all a delegate is a promise of a certain class that it's going to implement certain methods. So the way you give a class a delegate is you go up here to SK scene. You just put a comment here and you're going to say, okay, so the game scene is going to conform to the SK physics contact delegate. And now you're going to notice it's going to give us, actually, let's see if it even, okay, it's not going to give us an error. Some delegates will give you an error because they have a required designation for some of their methods, but it looks like this one doesn't. But the method that we need to implement for the physics delegate is going to be something called did begin contact. So anytime two physics bodies come into contact, they are going to call this method. And so you can do whatever you want in this method when two physics bodies run into one another. So to keep this organized again, I'm going to say mark. This is going to be the SK physics contact delegate. And I'm not sure if I've actually gone over this, but if you put a mark here with this dash and colon, you can actually go up to this right here, and you can see that it kind of bolds that. So if you want to keep your methods kind of organized, it's a really good way to do that. And I would highly suggest you doing that in future projects. So cool. Just to make sure this is working, we're going to say println did begin contact called. So if we set up all of this correctly, it is going to println this did begin contact called. So if we tap, awesome. So it looks like anytime our hero runs into one of these blocks, we're getting a call. It's calling that function there. So now instead of just printlning that, we're going to do something interesting with it. So here I'm going to create a new function. It's going to be the game over function. And this is just going to be called anytime a hero runs into the wall. And again, I'm going to put mark. I'm going to call this just the game lifecycle category for our start and game over. And okay, so now we need to implement our game over method. Now there's actually quite a bit of stuff we have to do. We have to like stop everything in the scene and make sure all the generators have stopped as well before we actually are going to be able to restart the game. So the first thing we're going to do is we're going to create a variable at the top. You know, we have this is started Boolean variable. We're going to create another one, and we're going to say this one's going to be called is game started, or is game over, my bad. And we're going to set that equal to false at first. So as soon as this game over method is called, it's going to set this is game over variable to true. And what this is going to do is it's going to be able to let us indicate when the game is over so that when the user taps again, it's going to restart the scene. So let's implement the rest of this game over method, and then we're going to add in that is game over Boolean here to the touches began method. But now we actually need to stop everything. So I'm just going to put a little comment in there called stop everything. To do this, we're just going to set the hero's physics body to nil. So you want to make sure that the hero stops interacting with any of the walls there. We want to stop all the walls in the wall generator as well. And to do this, we're going to need to implement a couple more methods in the wall generator, because as of now, all we have in the ML wall generator is a way to start generating the walls. We need a way to stop generating the walls and also stop all the walls in their tracks as well. So in order to do this, we need to have our ML wall generator actually keep track of the walls that it's generating. And to do this, generally a good way to keep track of things that are getting generated is to create an array of those things. So in our ML wall generator file, I'm going to say var walls ML wall. So this is saying is, I'm going to set that equal to an empty array of ML walls. So now that we created this empty array, I'm going to, anytime we create or generate a wall, I'm just going to say walls.append wall, this wall that we initially created. So now that we have that, we can keep track of all this. So I'm going to create another function. It's going to be called stop walls. And so what we need to do is we need to stop generating walls. So I'm going to create a function up here. It's going to just be called stop generating. All this is going to do is it's going to nullify this generation timer we have, because that's the only thing that's keeping the walls coming constantly. So this is really easy to do. All we have to do is say generation timer dot invalidate, and this invalidate function is just going to get rid of that timer completely, and it's just going to stop the timer. And it looks like this is probably an optional here. So if we say this, we're going to get no error. So under the stop walls function, we're going to say stop generating. So it's going to stop generating the walls. And it's also going to, we're going to grab every single wall in this walls array. And we're going to say wall dot stop as well, because we want to make sure that wall stops. But you can see here it's going to give us an error because we also have to go into the ML wall class right here, and we need to create a stop function for our walls. So if you click on the ML wall class, and I'm actually going to call this stop moving, just so we can remain consistent with this start moving. So I'm going to say func stop moving. And all we need to do, it looks like, when we started the moving of our wall, we created this action and ran it. So all we need to do is remove all actions, and that should stop the wall from moving. So sweet. It looks like we have our wall generator all set up to stop itself. So we can go into our game scene, and we can say wall generator dot stop walls. So let's see what we have so far here. We have to make sure the game over method gets called. So let's say game over, just to make sure, or just to see what we have coded out so far. So we're going to tap to start. When we run into one of these walls, you're going to see, awesome. So our walls stop. That's all that we've implemented so far. It looks like what we have to do now is we have to stop this ground, and we also have to stop our hero from animating. So let's do those two things right now. So we're going to do a similar deal. Let's go into our ML moving ground class here. And it looks like we have this start function to start it. Let's create the stop function. And again, just like the walls, we're going to say remove all actions, and that should stop our moving ground. So I'm going to say moving ground dot stop. Awesome. So that should fix that. Now, if we go into our ML hero class, it looks like we created the stop function, but we only created the stop function for the body so that he kind of stopped that breathing animation. We also want to stop his legs from moving. So we want to say left foot dot remove all actions, right foot dot remove all actions as well. And now we can say hero dot stop, and that should stop him as well. So let's run this. Let's just make sure that all the things are stopped that we want to be stopped. If he runs into the wall, awesome. So our hero stopped, the wall stopped, ground stopped. Everything's great so far. Now we want to, you'll notice also we can still keep flipping. We're going to change that because we know that when we want the user to tap again, we want the game to restart itself completely rather than keep flipping like that. Let's create just a quick label right here that says game over. So create game over label. It's going to put a quick comment in there. And this is going to be just like our start label. So I'm going to go through this pretty quick. I'm going to set that equal to game over. Let's set its font color to, oh, I didn't type that right. Game over label dot font color equal to UI color dot black color. We want it to be Helvetica again. And then again, guys, if you guys want to change any of this, be my guest. I actually encourage you to change and customize this game because that's where the fun of coding actually is. You can customize anything and make it anything you want. So we're going to set its X position to the center. We're going to set the Y position a little bit above the center here. Dot Y plus 40. Game over label. Dot font size equal to 22. And finally, we're just going to add that child. Awesome. So I know that's going to work, so we're not actually going to demonstrate that just yet. What we're going to do is we're going to go into our touches began method, and we're going to use this isGameOver Boolean value now. So I'm going to say, we actually have to change this first initial statement. We have to say, so if the game is over, so this is the first thing we want to check. If the game is over, what we want to do is we want to restart. So we're going to create another method in our game lifecycle methods called restart. And what this is going to do, it's just going to restart the scene. It's going to create a new scene and restart it. And so if the game isn't over, you want to check the other conditions that we had for starting and flipping, and that should be good. So in our restart method, all we're going to do is we're going to create a new scene, kind of like we did at the very, very beginning. If you guys remember, in our game view controller, we had this junk where we presented a scene to the view. So let's do that right now. I'm going to say let new scene equal a game scene, and the size is going to be our view.bounds.size. So that's essentially what we did right here. We're just using the view of our current scene. I'm going to say set the scale mode again to .aspect fill. And last but not least, I'm going to say view.present scene, new scene. So this is all great. This is going to present a new scene, but one thing we need to make sure, you always need to make sure when you're presenting a new scene or going transitioning elsewhere, is you need to make sure that all of your current timers are invalidated and nullified. So we nullified all the timers that we had for our wall generator, but for our cloud generator, it looks like I think those are still generating. So let's go into our ML cloud generator class. All we want to do is we want to create a function that's going to stop the generation of these clouds. So I'm going to say func stop generating. It's going to be our function. Whoa. Okay, there we go. And all I'm going to do in this is say generation timer dot invalidate. And that's just some housekeeping stuff just to make sure we don't have any running timers. Otherwise, it's like, if you think about it, if we present a new scene and the other scene essentially disappears, this timer is going to still be going, and it's going to try to add a cloud to that scene that doesn't exist. And it's going to throw you an error, and it's going to be bad. So just want to make sure that doesn't happen. So with that, if we run this, I think we're at the point that we want it to be. So we're going, oh yeah, dodging, oh no. We hit the block, it gives us the game over label. If we tap again, awesome. It looks like we're all good. So yeah, that's gonna be it for this video. I know that was a lot of stuff to cover, so if you guys didn't understand it completely, I don't know if you want to rewatch it, or if you didn't understand it, that's awesome. And yeah, in the next videos, we're going to cover some animations. We're going to get this guy kind of flinging himself off when he hits the wall, and maybe animate these labels a little bit too. So thanks for watching, guys, and I'll see you guys in the next video.